Number 5, write the pair of parametric equations, x equals 12 cosine theta and y equals y sine theta in rectangular form. Now remember, whenever we have to change from parametric to rectangular, we have 2 steps. We always solve for either what is shared or solve for trig. In this case, we're going to solve for the trig equation, which means either the sine, cosine, tangent, cotangent, secant, cosecant, those type. And then we're going to substitute. Now, if you're solving for trig, you're going to substitute into the Pythagorean identity. Since this is cosine sine, when I look at my formula chart, I should be substituting into the Pythagorean identity with sine and cosine. So I'm going to substitute into this formula. Sine squared plus cosine squared equals 1. So I'll just write this off to the side for now. Sine squared theta plus cosine squared theta equals 1. So let's come back up here, and we're going to get it into that form. So to solve for the trig, the first thing I would do here is I would divide by 12 on both sides, which means I have x over 12 equals cosine theta. Now, I've solved for the trig, I would substitute it here, which means it's going to end up being squared. So I'm just going to square it right here, just to make it easier when I move it over. So we'll square both sides. So now this is going to be exactly the same as this equation, because we'll have cosine squared on the right. On the left, we'll have x squared over 144. Because again, when you square a fraction, you just do top times top, bottom times bottom. So that's what's going to substitute in for cosine squared. Now let's figure out what's going to substitute in for the y, or rather for the sine squared. So I divide by 9 first. That goes away, and so I have, not a x, I'm sorry. I'll have a y over 9 equals sine theta. And again, I needed to make it sine squared. So just to save us a little time, let's do it over here. We're going to square and square. So I have y squared over 81 equals sine squared theta. Now that I have these two, I'm going to substitute them in. So I'll pull this equation over here, and we'll substitute. For sine squared, I replace that with this, which is y squared over 81 plus, instead of cosine squared, we go x squared over 144, and this is going to equal 1. Here's my rectangular equation. This would be my answer here. And we could graph it to check. We want to check to make sure we got it right before we finish off. We go over to our graph. And I'm going to do a new document here to clear that out. Graphs, menu, graph entry, parametric. And the equation they gave us was 12 cosine theta, 12 cosine. Now, in the calculator, we don't put theta, we put t, because that's what it wants for parametric. And the other equation was 9 sine theta, so 9 sine t. And now, hit enter. We see that we have this huge graph. Let me zoom out a little bit, zoom out. We can see we have this huge ellipse. Now, since we think it's ellipse, let's go to graph entry, equation, ellipse. I'll hit this form, and let's type in what we got for our answer. There's nothing with the x and y, but underneath x squared is 144. Underneath the y squared is 81. So there's nothing with the x, but underneath it we need to have 144. Since it already says squared, I'm just going to do square root 144. And over here, we'll do square root 81. Again, you could type in 9 if you wanted to, but these, I'm just canceling them out so I can see that the numbers are exactly what I had. I press enter, and look at that, it's the exact same equation. So we did it correctly.